So here's what we're doing here. This is what's called an identity. On a really basic level, this is the sort of question you're being asked. If I said 3x plus 5 equals ax plus b, on a really simplistic level, there's 3 x's on the left, which means there has to be 3 x's on the right. That means a equals 3. There's 5 numbers on the left, which means on the right hand side there must be 5 regular numbers as well. That means b must be 5. On a really simple level, that's what these questions are. Now, obviously not going to give you something that easy. So, what you do is you multiply them out, and you get 2px squared plus 2qx. You're all well capable of doing this part. And then plus kq. That's the left side. I now go to the right side and I multiply it out like this. I don't multiply the r. Why do I not multiply the r? It's outside the bracket there. So we have 2qx minus px plus r. Then on a really simplistic level, I look at each part individually. I look at the x squareds, I look at the x's, and finally I look at the numbers. The two of them can cancel because they're exactly the same. Shh. Excuse me. I'd actually, also I'd do is write this down. I would have wrote down 2px squared equals 2px squared, and then you'd be like, nothing to learn there. Of course they're equal to each other, so you don't really spend too much time doing that. Then you go and you look up at the x's and you go, okay, on this side I have 2qx, I have plus kpx, and then on the other side I have a 2qx and I have a px, and what Josh said is right. Look, the two qx's are the same. There's nothing to be learnt there. And what I have is kpx equals minus px. I can cancel the x's off both sides, can't I? Because they're both being multiplied, yeah? If this was a plus x, I can't cancel the x's. It's not being multiplied. But because both sides are being multiplied by x, I can divide both sides by x, and all that does is cancels off the x's. Yeah, we're going to get there as well. And we're also going to cancel the p off both sides. What I can do is this, right? See the way I divided both sides by x? I can then divide both sides by p. And what I'm going to get, k equals minus p divided by p, or minus 1p divided by p. Just minus 1's left over. And if you look at the description of the question, it's asking you that it is proved that's minus 1. Yes? The next thing I'm doing is I'm going to work with parts that have no x, okay? So we figured out that k equals minus 1. That's great. We keep it there. Now, the next part is what we refer to as numbers, but numbers actually can also be letters, okay? So these letters have no x in them. See the way this part here? Oh wait, never used that one. I must learn my lesson. This one and this one. These are the only parts that have no x in them, correct? So what we can do next is we can balance them up together and we get kq equals r. What did we learn about q from earlier though? Minus 1. So minus 1q equals r. What does it want from the top of the board? It wants me to show that q plus r equals. So what could I do with the q? Bring it over, because there's a 0, isn't there? So I'd like to make a 0 somehow. So I get 0 equals r plus q. That's the same thing as me saying q plus r equals 0.